Welcome to this lecture review on IPv6 fundamentals. We're doing Chapter 8, DHCP version 6. Again, this is Dynamic Host Control Protocol for IPv6. All of this material goes to Rick Graziani. He wrote not just the book that we're using, but the PowerPoints as well. Again, all of this material is Rick Graziani's. I'm just doing a video lecture on this material for one of my courses. You can buy the IPv6 Fundamentals book, written by, again, Rick Graziani. I have the number there. You can also buy his fundamental videos, which are also there. So let's go ahead and jump right in. Let's talk about the router advertisements and DHCP version 6. So where does this kind of come into play? So we're dealing with global unicast, we're dealing with dynamic addressing. We've already finished our Slack of DHCP. Now we're talking just straight DHCP. So we're going to talk about Slack with DHCP, DHCP, and DHCP-PD. So dynamic IPv4 allocations, again, if you grab them dynamically, a client would request from a DHCP server, and then the server would apply the appropriate information as outlined. All dynamic addressing begins with the router advertisement, RA message, and essentially what's going to happen is the router advertisement will send a ICMP version 6 RA out to its LAN, and it will suggest to all IPv6 devices on the link how it will receive the appropriate IPv6 address information. It's sent periodically by the IPv6 router, or when the router receives a router solicitation message from a host. The host will send a multicast to all IPv6 routers, hey, I need an address. That will come in the form of a router solicitation message. The router will send a multicast to all IPv6 devices. Let me tell you how you're going to do this. And it will respond with a router advertisement. And the server, again, may or may not be needed. Router advertisements, 3 options. We can do Slack, no DHCP, which that's the default. Basically, the router is everything that you'll need. Option 2 is Slack Stateless DHCP for DNS. And basically, here's my information, but you need to get other information, such as the DNS settings from the DHCP server. So all the addressing, except for DNS, will come from the router. Third option, all addressing except the default gateway will be used DHCP. Basically, the router is saying, hey, I can't give you anything. Here's the information for DHCP server. And I'll send this as a router advertisement. Options 1 and 2 are stateless address auto configuration. Option 3 is a stateful address configuration, not auto. Here are the big 2 that are going to be addressed. So, the type of router advertisement option depends on 2 RA flags, other configuration flags, and managed configuration flags. By default, both flags are set to 0, option 1. Use me, the RA, for all your address information. No other information is needed, hence no DHCP server. Other configuration flag set to 1. That's going to be option 2. And that's going to be, again, basically, you're going to get the DNS information from the server. Use me for the addressing, get other information from the stateless DHCP server. When the managed configuration flag is set to 1, that's option 3. And that's going to, again, all client information will be received from the DHCP server. The router will not be managing any of the addressing, just DHCP. So again, if it's other configuration and manage configuration 0, option 1. When it's other configuration flag 1 and manage configuration flag 0, it's going to be option 2. Slack with stateless DHCP for DNS. When other configuration is set to 0 and manage is set to 1, that's going to be option 3. And that's get all information from DHCP. Again, pay attention to where the flags are at, and that dictates if it's option 2 or option 3. So option 3 and the A flag. That's going to be the address auto configuration flag. The autonomous address configuration, A flag, tells the host that they can create an address for themselves by combining the prefix in the RA with the interface identifier. Again, because that's going to be for the auto configuration. Option 3, manage configuration 1. Auto configuration will also be set to 1, hence the prefix in the RA will be used for Slack. Use a Windows host, I will use the RA prefix to create a temporary Slack address until it receives one from DHCP. Option 3, all addressing except the default gateway is going to be off the DHCP server. Again, that's going to be a managed configuration flag 1 and the non-default standard of auto configuration set to 0. Thus, no prefix will be used. If 1 is set, which is set by default, use the prefix. If 0 is set, you have to get the address from IPv6 DHCP server. So again, if the A flag is set, no Slack, no prefix from the RA. So obtaining an IPv6 address automatically, as long as it's set to use the information automatically, you should be able to get it, because it should be automatically set to be configured. Alright, so let's move on to the stateless DHCP version 6 material. So Slack again was discussed, chapter 7. We're moving on to additional material. Again, options 1, Slack, no DHCP. Option 2, Slack with stateless DHCP for DNS. Option 3, everything goes to DNS. Here we're looking at option 2. So router as a stateless DHCP server. The ICMP will come from a client. An ICMP router advertisement will go back to the client with, again, the options flag set to 1 and the management flag set to 0. That's going to force it to use option 2. And it will create its own address, stateless, and it'll have the default gateway, but it'll have to find the DNS. That's where the DHCP functionality will come into play, and basically it will send a solicit to all DHCP version 6 servers as a broadcast, and a advertisement unicast will come back from the router or DHCP server, because in this case it's going to be the router. An information request to all the DHCP servers, and then a reply, which will be unicast. The domain name and DNS server lists may include, if the router and the end system support, again, the RFC 6106 IPv6 RA options for the appropriate DNS configuration. So setting the other configuration flag, setting that O flag. Basically, you go to the appropriate interface, IPv6, ND, other configuration flag. That will allow us to set it. This will send out a stateless all IPv6, so a multicast address, from its link local address using the appropriate prefix and the prefix length and the other configuration flag. That will go into a router advertisement. The client will take the prefix and its MAC address and put it together. The default gateway will be added in. Global class unicast address is going to be the prefix plus interface ID. It will use the EULA 64 process or a random 64-bit value for that interface ID. But in reality, for what we're doing, it will pick up the appropriate options. The flag, other configuration flag, when it's set to 1, will also query the stateless DHCP server for DNS. So how do we enable IPv6 routing to send the appropriate ICMP version 6 router advertisements? Turn on IPv6 unicast routing. Configure the stateless DHCP server parameters. If we're doing this on the router, again, it's a pretty basic DHCP pool. Here we're using IPv6, so make sure to do IPv6 DHCP pool, the pool name, the appropriate DNS server, the appropriate domain name. No client address information will be listed here. Then we're going to configure the interface that the message will be sent on. Interface, again, the name of the interface. Again, IPv6 ND other configuration flag. That will set the other options to option 1. Then you can also pull the IPv6 DHCP server pool name. That way it will actually pull from the correct pool of DHCP. Just in case you have multiple DHCP configurations running. Again, it's just going to pull the pool name from up above. DNS. Again, it will create its own stateless address. It will pull the DHCP server, and it will pull it over. Here's the example of configuring it all the way through. Setting up the pool name, setting up the DNS and the domain name, setting up the appropriate interface with its address and local address, and again, setting up the appropriate other configuration flag, and then also setting up the DHCP server options so the client knows where to reach the DNS, because it's going to pull from that pool that you've listed. RA will be sent because that command right there is used, IPv6 and the other configuration flag. That sets the other advanced flag set to 1. And then once it gets its address, it'll look for DNS, which that one will know it has to be sent to the DHCP server. The router will pull that information from the DHCP server, and here it's also the router, and it will pull the DNS settings and the domain name settings from that pool that's listed under the interface. There we go. That's the two major configurations for DHCP pools and IPv6. How can we verify on an individual PC? You can always do the appropriate ipconfig/all, and that will show you the appropriate settings. Here is again the IPv6 address, its default gateway, its DNS server, and DNS suffix. Again, it's going to be using stateless for the auto configuration of its IPv6 address. If we want to do a look at the interface itself, we can do a show IPv6 interface for the interface we want to do. Here we're doing gigabit 00. That will show you it's an IPv6 interface, its link local address, its global unicast addresses, host used, again, the stateless auto configuration, and you can also list the host used DHCP to obtain other configuration, because it will recognize that the RA is being set to 1. Auto configuration, and to obtain the DHCP or the DNS settings via DHCP is the next line. Let's move into the appropriate stateful DHCP. Alright, moving on, let's talk about stateful DHCP. Again, that's going to be option 3. All addresses except the default gateway will come from the DHCP server. So how does this work? A client will send a RS, the router will send an RA. Again, the managed flag will be set to 1. That in turn tells it that it will be doing a stateful DHCP request. Basically, I'm the only one using the default gateway from this address. I need to contact the appropriate DHCP server for the rest of the information. It will then send a broadcast, an Unicast to all DHCP servers. It will be a solicited message. The DHCP server will respond via a Unicast address. Once the client receives the advertisement, it will send a request, again, to all DHCP servers, and then the DHCP server will send a Unicast reply, giving it all of the information that it needed. So again, option 3, the management flag is set. How do we configure it? We configure it with the ND. Go to the interface, IPv6, ND, manage-config-flag will set the managed flag to 1. That will allow DHCP to take over. As a Windows host, it will still use the RA prefix to create a temporary slack until it gets the information it needs from the appropriate DHCP server. Again, it's a temporary address, and it will be used as the source address for the originating contract connection, while the external host uses a public address by querying the appropriate DNS setting. You can set the appropriate prefixes underneath the interface, IPv6 ND prefix, give it the prefix length, and you can turn off auto configuration with a no-auto-config. Again, the no-auto-config is an option. It indicates to hosts on the local link that specified prefixes cannot be used for Slack. The prefix will be advertised with the A bit cleared, meaning no auto configuration. So how does this actually work? The RA will send a multicast to all IPv6 devices, link local, prefix length, managed flag set to 1. The client will get the link local address as the gateway, and once it sees a managed configuration, it knows to contact DHCP for a global unicast address. And then it will do a unicast to DHCP server. Again, it will do a temporary slack. If the autonomous address flag is set to 0, no slack. So again, enabling IPv6 routing to send the appropriate ICMP messages. IPv6 unicast routing. Step 2 is configure the stateful DHCP and the parameters. Again, setting up the appropriate pool and pool name, address prefix, DNS domain names, and then we have to also program it on the interface. So again, navigate to the appropriate interface, go ahead and set the managed configuration flag, set the appropriate prefix, no auto config, and then set up the appropriate DHCP server with the appropriate pool name, same as the pool name above, and that will issue that address information from that pool name. Here it is in an already configured state using global unicast addresses. Again, turn on IPv6 routing. Go ahead and make sure that you set up the appropriate pool name, and that needs to match the actual pool name. That's going to be the DHCP server settings. You could also do the exclude lists, so including only valid addresses to be assigned. With IPv4, when you did DHCP, you had to specify exclude addresses. All other addresses are included. With IPv6, a router enabled as DHCP server will specifically include addresses to be assigned. All other addresses will be excluded. Using the prefix length of the LAN, the router address and other statically assigned addresses will be excluded. So again, use the appropriate prefix and slash notation so you get the appropriate addresses. Here we have again including specific addresses, how we do the calculation to verify. That gives you the appropriate network. All other addresses will be excluded. Verifying, you can always do an IP config on a individual machine, and you should get the gateway, its global unicast address, its prefix for DNS, its IP for DNS, its domain name for the specific DNS suffix, as issued by DHCP. If you want to look at it from an interface standpoint, show IPv6 interface and the appropriate interface. You can see that it will grab, if it's using DHCP, it'll highlight a host using DHCP to obtain routing addresses. That's how you can verify it's getting the appropriate information. Here's stateless and stateful DHCP servers. So again, we have two pools going on two different interfaces that are set up differently. Notice with stateless, it's just DNS settings. With stateful, it's a prefix and the DNS settings, and the appropriate mappings for each one to verify. Next, let's talk about DHCP version 6 relays. So again, the relay is going to have to forward DHCP messages across the layer 3 boundary. So you navigate to the appropriate interface, you set up IPv6 DHCP relay destination, and you put in the IP address or exit interface. Relay agents create a relay forward message containing the original DHCP message from the client and then forwards it to the appropriate server. Here we have a client requesting DHCP. The relay forward will send it to the DHCP server. The IPv6 address can be a unicast or multicast address. The link scope, which is the output interface, must be specified for this kind of address. So here again, we're enabling IPv6 unicast routing. We're going to be programming that interface. We're going to be doing a managed configuration. We'll be setting the relay destination to another IP address and the exit interface. Again, only required if the link local address unicast is used. If we're not using a link local unicast address, we do not need to put the exit interface. When the destination of the DHCP server is a global unicast address, no multicast routing is required. DHCP will relay forward it to the appropriate DHCP server, and it should respond. If we're doing, again, managed configuration flag, If we are doing a DHCP relay destination, you'll notice here we don't have to do the appropriate exit interface. When the destination of the DHCP server is a FF05, basically that's a multicast address to all DHCP servers, then we need the multicast routing enabled. So that's when we add an additional command, IPv6 multicast-routing, and that turns on multicast routing for IPv6. DHCP will forward it to all DHCP servers, and one will respond. Next section, 8.5, DHCP version 6, prefix delegation process. So the nice thing is with prefix delegation, we have a structure. So the ISP is only going to deliver to a public IPv4 address for the home router's interface. That's going to be slightly different for IPv6 because with IPv4 that's how we can mask them. That process is called NAT, but it has its drawbacks. No NAT between public and private IPs always in debate. So if we assign a global IPv6 address, we can verify end-to-end reachability, because we can start assigning all global IP addresses behind our router, because they'll get their own prefix, part of the public addresses. So no NAT, and it will use DHCP PD, the prefix delegation. So an ISP router is known as the delegating router. Our home router will be our requesting router. So the first home ISP facing the internet will need an IPv6 address. It will get it one way from the designating router. Slack or Stateless or Stateful, somehow it will get it. So what about our internal network? How will our internal devices get a public IPv6 address? So that's part of our dilemma. So the home requesting router gets its IP address from the ISP facing router. Then step 1 will request a prefix for its LAN. The subnet, the prefix for its LAN is optional, but it gets a /48, but is assigned typically a 64. It assigns an IPv6 address from the prefix to its LAN, advertises the prefix in a router advertisement device on the LAN, and that's how it works. So how does that work that's how it works conceptually. How does it work actually? Basically, the home will ask the ISP for an address to allocate to its LAN. DHCP requests. The ISP designated router will send a reply with the prefix /48. The RA, the requesting router, will send that prefix, typically as a /64, back to all of its clients on the LAN side. The home assigns an address from the prefix to its LAN interface and advertises that prefix using a router advertisement message. Home assigns the prefix or subnet of the prefix to one or more of its interfaces, again typically with a /64. Now let's go ahead and talk about DHCP version 6 PD configuration examples. So let's talk examples. So here again is our home router, router advertisement. It will delegate the appropriate prefix, send it as a DHCP PD. The home router will use one ID for its LAN, and the rest of it for its internal network. It will use Slack for the rest of it. So let's look at another process. So a router solicitation message, a router advertisement coming back from the ISP. Other options are stateless and stateful DHCP for our internal addresses. So again, DHCP solicitation messages, the RR must be enabled with the appropriate PD option. Advertisement, requests, reply including the prefix, And again, Slack will send it on the LAN side. Part of that configuration again is setting up on the home router unicast routing, setting up the appropriate auto config, setting up the DHCP client PD and the appropriate client pool, and that way you can get the appropriate prefixes and everything to hand out to the appropriate gig interface. Here they're going to match up. Part of that request is going to go to the pool on our LAN side. The reply will actually include the DHCP pool options. Again, it's going to do a 48-bit response that we will turn into a 60/64 and the appropriate subnet ID, interface ID, and appropriate prefix length, because remember, it's going to convert that /48 into a /64. You have to make sure that unicast routing is enabled throughout, though. Looking at the ISP, or the designated router side, again, IPv6 unicast routing. You have to make sure that you're setting the addresses and link local addresses, setting up the appropriate DHCP server for the client addresses. Again, you're going to have to create a DHCP pool and a delegation pool with the appropriate DNS and domain name services, so that as things come in as a request, you can make sure to reply to them. That DHCPv6 PD pool you can set as a local pool as a /40 or 48 to be able to send to the home routers or the requesting routers as they request them. Again, they're going to request it and they're going to be able to hand them out. Here's going to be again the DHCP pool section, and again the local pool section. You're going to reserve a /40 to allocate the addresses for ISP so that DHCP client will be able to use them. From the /40, each DHCP client will get a /48. So we can get several /48s in that pool. And it will just respond with one of them. So we'll send a reply with a /48 to one home requesting router. Again, we'll take the appropriate information and plug them in and convert it to a /64. Alright, so let's talk about how we verify DHCP. So part of that verification is going to be, again, looking through the show commands, making sure that our pools are set up correctly, looking at the appropriate client addresses, making sure they're handing out correctly, looking at our local pools, understanding the /40, and have that /40 assigned to the /48s. Understanding how the reserve of that /40 works. Understand the entries for them. Understand that you have to make sure you have unicast routing turned on for IPv6. Making sure you understand the prefix from the ISP commands so that once we get them, we can plug in the appropriate options. Understanding Slack. Understanding the internal interface. Understanding, again, this portion right here, the interface and the appropriate /64. Understanding the, again, prefixes and the internal addresses. Understanding how the writing advertisements work and how Slack works. How the ND default allocation works, assuming auto configuration is turned on. How the default route works back to the home. And that's actually this chapter, well, this area in a nutshell. Again, all of this information came from the IPv6 Fundamentals book, written by Rick Graziani, All information is provided by his book. All rights for all of this material is his information. Here's the last slide with his email and contact information. I want to thank you.